Hello and welcome to our joint webinar between Simba Technologies and Microsoft. I am Matt Begg, Director of Program Management at Simba Technologies, and I will be your host for today's webinar. Our topic today is ODBC 4, the new specification for modern data sources. Simba's involvement with ODBC goes back to 1991, when Simba partnered with Microsoft to develop the original ODBC specification and created the first ODBC driver for Windows. We are very lucky to have Michael Pizzo here with us today. Michael has worked for over 25 years in the design and delivery of data access solutions and APIs. Michael was active in the initial design and standardization of ODBC, sitting as chair for the SQL Access Group and member of the ANSI and ISO committees through the evolution of ODBC into the ISO SQL CLI. Michael has been a key designer and contributor to ODB, ADO.NET, and the .NET Entity Framework, and the Open Data Protocol, OData. And today, Michael joins us to give you an overview of the changes coming in ODBC 4, what problems does it aim to solve, and how the community of ODBC developers and users will benefit from its adoption. Following Mike's presentation, we will open the floor for your questions and comments. Please don't wait until the very end. Send your questions by typing them in the questions window, and I will try to read them all to Michael. If we run out of time before we get through all the questions, we will forward them to Michael and publish them along with the answers and the recording from this webinar on Simba's website. One important announcement. To protect the intellectual property around ODBC, any feedback provided during the webinar is covered under the contribution agreement that you will be required to accept during the registration. If you are unable to abide by those terms for any reason, you're still welcome to attend but should not provide feedback. If you would like to tweet about this event, please use hashtag ODBC4 so we can easily see your tweets. That is hashtag ODBC4, the number 4, one word. Michael, please take it away. Yes.
Okay, great, thank you. Just trying to get a little bit of logistics worked out. Thank you, Matt. As Matt says, I worked on the initial version of ODBC back, I hate to say it, 25 years ago with Kyle Geiger. I have participated in the ODBC design and delivery through the standardization with the SQL Access Group, ANSI, Open, and ISO. And it's actually very exciting to be looking at ODBC again and revising it after all of these years. Before we talk about what ODBC 4.0 is, we should talk about kind of what ODBC is in general and how it came about and where it is today. Prior to ODBC, the ANSI and ISO standards committees have been defining a common syntax for database requests called SQL, for structured query language. And that structured query language gave you a common way that you could ask a question. What are all of the orders over a certain amount? But there wasn't a common way for an application to deliver that question to a database. So typically, the way that applications talk to databases was through embedded SQL. So that SQL text was actually part of your application code. It was compiled into your application. A pre-compiler took that text, generated the appropriate commands in order to connect to a particular database, and your application was hard-coded to that one database. And if you wanted to talk to a different database, you typically wrote a different application. You might have switch statements inside to talk to two databases, but there wasn't a way that you could arbitrarily plug in additional databases. I was in the Excel team at the time that we started really investigating ODBC, and we recognized that Excel was a great tool for analyzing data, and we wanted to be able to get that relational data into Excel for analyzing it. And people were using Excel to analyze the data, but the way that they were doing it is they were submitting a request to their DBA. Their DBA would give them the printed out report a few days, a week later. They would type it into the spreadsheet, and then they could graph it and chart it. And oftentimes mistakes were made in the translation, there was delays in getting it published, and then they had to do the same thing every month for a monthly report. And so we wanted a way that Excel could talk to a relational database and get the data out of that database without having to pre-compile into the Excel application knowledge of each database that it was talking to. And so we decided to follow a model very much like the printer model in Windows, where an application doesn't know about all printers when it's written. It talks to printer drivers, and those printer drivers expose a common API, and that API allows the application to connect to the driver, to issue commands against the driver, and then the driver goes off and does its printing. So ODBC was designed as a very similar technology, a driver technology, where instead of a printer driver, we had a database driver. An application would speak to that database driver through a common API and use that to submit SQL requests. So we stuck with the SQL language, but it was a common way that you could connect to the database. You could find out schema about the database. You could submit your requests to the database, and you could retrieve and bind results into your memory buffers in a dynamic way rather than pre-compiling it into the application. So from the very beginning, it was designed as a very efficient, very low-level, C-oriented API that was designed to let the application be in complete control of how memory was allocated, the data that was bound, the data that was selected. It allowed the application to introspect the driver to find out certain things about the database and how to tune its requests against the database. And then it was designed so that the drivers could very efficiently stream the data off the wire into those bound buffers that the application specified. So those were sort of low-level concepts that were very fundamental to how ODBC was designed. It was designed based on the fact that the application could find out from the driver ahead of time what the data looked like, could set up these buffers, and then the driver could very efficiently pump data into those buffers. Where the data was large and you couldn't pre-assign buffers, there was a chunking mechanism that allowed you to kind of stream data in chunks into the application. But again, the application was controlling how the memory was allocated, how the data was copied into the memory, and the driver was able to just read it off the wire into those application memory buffers. As I said, we didn't define a new syntax. ODBC uses the same ANSI SQL syntax that ANSI ISO had defined. It just provided a way that you could submit that syntax through a common mechanism and bind the results that were returned from that. The ODBC API, we worked through a standards committee, and we eventually standardized the ODBC API as part of the ANSI ISO SQL 1999 specification, a portion of that specification called the Call Level Interface, or CLI. Since then, ODBC has been widely adopted both by database vendors and ISVs such as Simba, who build drivers on behalf of other data sources or on behalf of clients who want to consume data for those particular data sources. ODBC is supported in Windows, Unix, and Mac environments. And although it was designed for relational data and it was very tied to the relational data in SQL, we see more and more, because of its ubiquity, because so many clients are using it, people want to start plugging other types of data into it. And so people are trying to use ODBC to work with non-relational stores. And as Matt says, they've had some success in doing that, but it's been a real struggle, because in order to use ODBC as it exists today over a non-relational store, you have to make it look relational. You have to flatten the data. You have to stuff that square peg into the round hole. So what is ODBC? So let's get into some of those challenges in a little bit more detail. So again, one of the reasons we ODBC was designed around relational concepts where the data was very normalized. You had rectangular tables, and they had relationships to other rectangular tables. You didn't have nesting. You didn't have you knew the columns up front. You never were surprised by a different data type or a column that you weren't expecting. So it's a very rigid world. It was a very normalized world. And the relational model was designed as a storage model where there was a great deal of integrity enforced because data wasn't duplicated. It wasn't normalized. It was never designed really as a user, an end user model for accessing that data. And so concepts like more natural representations of the nesting of the data wasn't something that was important to the relational world. However, the world has moved on. Even in the SQL world, there are things like UDTs and collections of that are arrays or multisets that allow you to start representing more complicated structures. And certainly there was a number of years ago, there was a NoSQL movement started that was really saying, we don't want to live in this confined rectangular world. We want data that has more interesting shapes, that better reflects things, that is more flexible, where I can add another column in a particular row without having to define it up front in a schema. Or I can change my mind about the type of a particular column, or I can have no schema at all. I can just have basically a document that represents the data that I'm interested in.